you have to solve this first order differential equation. A couple of things I'd like to say. First of all, that x is actually a function of t, so it can be written as x of t. This could be written as d on dt of x of t minus 6x of t equals 2. And this x of t, in the transform tables, it's represented by f of t on the transform tables. Another thing about it with the transform tables, the dx of t dt can be written as x dash t. And in this case, this dx dt up here is actually x dash t. Now there is no x dash t in the transform tables, but there is f dash t. There. Okay? So wherever we see the f dash t, we use our x dash t. So there are 3 steps to this question. 3, a lot more in the third step though. Step 1 is do a Laplace transform on every term. Okay. Step 2, isolate x of s. Get x of s on its own. And step 3, do an inverse Laplace transform. On x of s. So basically what we do is, when we do the Laplace transform, somewhere in the equation we will have we had little x's of t's, and they will become capital X of s whenever we transform them. But if you do a Laplace, inverse Laplace transform on x of s, you will get little x of t. Basically because if you do a Laplace transform on x of t, you will get capital X of s, and if you do it the other way around, you will get little x of t. Okay, so part 1 then, or step 1, let's Laplace the whole equation. So rather than call this x dx dt, I'm going to call it x dash t. So we have to do a Laplace transform on x dash t minus 6 times the Laplace transform on x of t equals the Laplace transform on 2. Okay, so these you have to go straight to the tables, right? Okay, so according to the tables, the Laplace transform on f dash t is this. I'll write that down. So in the tables we have f dash t, we do a Laplace transform on it, and we will get little s, capital F of s, minus little f of 0. Right? So if it was a Laplace transform of little x dash t, which is what we have, it will be s, capital X of s, minus little x of 0. The next part is the Laplace transform of x of t. It's not really in the tables. It would be f of t and it would be this, but that could be called capital F of s. So if you have a Laplace transform on little x of t, it is capital X of s. And the last part from the tables that you need to know is the Laplace transform of 2. That is a. A is like for any ordinary number, any number. So if you do a Laplace transform on a, you get a over s. So if we do a Laplace transform on 2, you will get 2 over s. So what we have to do now is put these values here into this equation. Let's try that now. So it's the Laplace transform of x dash t. That's this. So Laplace transform of x dash t minus 6 times the Laplace transform of x of t equals the Laplace transform of 2. From the tables we can now write that this is s capital X of s minus little x of 0 for the x dashed. Then minus 6 capital X of s equals 2 over s. That's step 1 done. Now step 2, we have to isolate x of s. That means we take this out. We can change this because the initial conditions were that x of 0 equals 2. So we can put that into this equation. That's a start and tidying it up. So we'll have s x of s minus 2 minus 6 x of s equals 2 over s. Take this x of s out, bring the minus 2 to that side. So we'll bring the minus 2 over first. S x of s minus 6 x of s equals 2 over s plus 2. Right. So we take the x of s out of these two, it's a common factor. X of s out, and we're left with s minus 6 equals, for this side here we should get a common denominator, and we could get s as a common denominator. If we multiply this 2 by s above and s below the line, really we haven't changed it because s over s is 1, so, but we still have a common denominator now. So that now becomes 2 over s plus 2s over s, s. So now we have the common denominator of s, and we have 2 plus 2s. So now all we do is bring the s minus 6 underneath here. So we have x of s equals 2 plus 2s over s on s minus 6. Right, so the next part to do here is to use partial fractions. That's what makes this part a little bit longer. Okay, this can be written then as, the reason we use partial fractions is we can use something like this. We get it something like this, we can work backwards. It's easier to work from. So that will become a over the factor s plus b over the factor s minus 6. Now this is the equation we're working with. If we multiply everything across by s times s minus 6, we will have 2 plus 2s over s on s minus 6 multiplied by s on s minus 6 equals a times s on s minus 6 over s plus b on s minus 6 over s minus 6. And we get cancellations. All of that cancels with all of that. And we're left with 2 plus 2s equals, the s's cancel here, a times s minus 6 plus the s minus 6 is cancelled here, b times s. So all we have to do is find a and b. To do this, I could say, first of all, let s equal 0. That would eliminate the b. So let s equal 0. And we will have 2 plus nothing equals minus 6a plus nothing. So that means a must equal 2 over minus 6, or minus 1/3. And then to get b, if I let s equal 6, that will become 0. A will be eliminated, so let s equal 6. We have 2 plus 2 6's are 12 equals 0 plus 6b. 14 equals 6b. b equals 14 over 6, which can be written as 7 over 3. So now we go back to the original of this here by parts equation, or partial fractions equation, and put in a and b. So we now have that 2 plus 2s over s on s minus 6, which is equal to x of s, is now equal to a minus 1/3 over s plus b 7 over 3 over s minus 6. And now we are in a stage that we can use the transform tables. So now step 3, this is step 3 actually. No, this is step 3 now. Do an inverse Laplace. So if we do L to the minus 1 of x of s, that means L to the minus 1 of 2 plus 2s over s on s minus 6, which is minus 1/3, bring that outside, on L to the minus 1 of 1 over s, plus 7 over 3 on L to the minus 1 on 1 over s plus 6. So now finally we have a look at the tables, and we can see that 1 over s on the tables would be a over s, which will give us a, which is just 1. So if we do that, that just becomes 1, and that becomes just minus 1/3, plus 7 over 3, and if we do the inverse Laplace on 1 over s minus 6, that's that one. So on the tables, so for this one here, do it up here, on the tables we have 1 over s plus a on the Laplace side, and on the function side we have e to the minus at. So if it's 1 over s minus 6, that is going to be e to the minus 6t. Yes, that will become a plus. Minus minus. So we now have that the inverse Laplace function of the original question, which was, the inverse Laplace of x of s is equal to 7 over 3 e to the 6t minus 1/3. That is actually now x of t, because when you do the inverse Laplace of x of s, you get x of t. So this is the solution. X of t is equal to 7 over 3 e to the 6t minus 1/3. That's the end of the question, but really, if you want it, you probably don't, but if you do want, you could check it. So if we go back to the original formula in the question was here, dx dt, x dt minus 6x equals 2. So let's just put in the value we get for x of t and see if that works out. So basically it's d on dt of 7 over 3 e to the 6t minus 1/3 minus 6 on 7 over 3 e to the 6t minus 1/3. And that should equal 2. So if we differentiate this is differentiation now, it will become e to the 6t 6 times 7 over 3 minus the third goes, so that we're going to differentiate it, so then it's minus 6 times 7 over 3 e to the 6t minus times minus plus 6 times a third, 6 over 3. They cancel out and 6 over 3 equals 2. Therefore this is the solution to that. Thank you.